with the hype of AI, the field of robotics is getting hot. And naturally, a lot of people are thinking to join this field, which is great. And even before you start, I'd like to share a couple of aspects that you want to consider, I would consider if I start over. Because number one type of question I receive from the people is that, hey, Elliot, I have this major like electrical, mechatronics, or mechanical engineering, computer science, everyone, right? But that's not really an important question because it's literally a question about you, whether you're valid or not. My friend, you're always valid. Instead, have you ever stopped thinking about you and then start thinking about what kind of robotics companies would want? Like what type of candidates are they looking for? That's the right question. So in this video, let's answer this question. To this end, I will answer a couple of my actual interview cases that I went through and some episodes from my work experience, and then why I wanted to create this ubcourse.com where I teach these robotics courses. And also I will go over how I would search for the job. Don't just type robotics engineering when you search for the job. So let's actually go over that and read a couple of job postings together, and then let's see what you want to prepare for those. And if you're new here, my name is Elliot. I'm a robotics engineer educator, and my mission is to help people land on this field of robotics as smooth as possible. Okay, to get started with, I think this is a good opening. So with the hype of AI and say embodied AI, the robot together, it's getting hot. And I think a lot of videos like these, the robot jumping and backflipping, looks very cool. I totally agree. And this is one of the reasons why a lot of people want to join the party. However, very first thing I'd like to point out is that this kind of functionalities like robot jumping and backflipping and all that is one of the 100 requirements from your users or your clients in general, not you. You are the engineer and then you need to solve these underlying technical problems while robot doing a certain things like this. So what could be underlying problems? Have you ever imagined? Have you ever tried to guess? So one thing I can imagine is this motion blur problem, but because the camera is really rotating fast because it's backflipping, and then look at this object detection algorithm. The images are really clean. However, this is actually not a motion blur problem, but this is actually the raw images from a different camera. For example, it's moving car, the camera on the moving car, and then there is a rolling shutter effect like this. So these edges of this car is kind of chopped as it moves. And then this kind of raw object detection algorithm may not work in this kind of pictures. And what's more important is here, you have object detection block here, like YOLO, VA, whatever that is, you name that. And then the output here is going to be fed into eventually somehow at the end on a very high level control block. Like motor control or BIDC motors and other control algorithms. And then any unexpected output directly towards the controller is very dangerous. The motor is actually going to overshoot. And you may hurt yourself. That was really stupid. Don't hurt yourself. Always wear the gloves and the face cover where you get near to your own robot after you just update a single line of code. And that's a huge problem in robotics, and you want to address all these problems. And again, when this kind of thing happens, it's not always cool. Okay, so far, I kind of made up these examples with the example of the object detection. The object detection algorithm may still work with this slight motion blur or this kind of rolling shutter effect, and may be fine. I just wanted to make a point, what could be underlying technical issues? Because object detection nowadays, it's kind of everyone can do. So what's more important is that with these basic algorithms, together with your robot may have some practical problems and you want to be able to solve them. Now, this is another point I wanted to make. So I didn't really apply for the researcher position, but however, some of the robotics companies may ask you to implement a paper by throwing you with a bunch of data and a research paper, and they might ask you to implement it in a couple of days and then share it with the GitHub, right? So I didn't go over all the details because it's their company's context, but what I wanted to mention is why do they ask this to the candidates? Because it's not even a researcher position, right? And then after you submit, you go through the interview, and then you will discuss why this kind of result came out, explain that clearly, and then how you would be able to improve it in the future, right? And then after all that, they still may reject you. But well, it's more like a technical interview process. I really want to give you the real process of the interview in general in robotics, right? But some other companies, they don't always have to, ask you to implementing a research paper. They may ask you just kind of like casual questions, seemingly casual questions, but it's really technical questions. For example, there was a robot company like the vacuum robot, that kind of companies, I think. Again, I didn't say their name or something like that, but the question is like this. When a user lift up the robot and then blocking the lighter view of the robot, what did you do as an engineer? And that's the technical question. And then right answer, to be short, is the implementing error state Kalman filter and so on and so on. Yeah, that's the kind of typical environment that you might go through as well if you are looking for robotics engineering job. So what the heck is all that? What is this EKF and why are they asking these really practical situational cases? So first question, why would they ask this PayPal implementation? Is that they want to test your mathematical knowledge or coding skills or communication skills? Or do they really want to verify whether you have like master's or PhD and something like that? Yeah, maybe. But here's more of my reasonable guess. Because the research papers like this, it's more like a game strategy book instead of game tutorial books. What the hell do I mean? Well, if you have ever played this video game, League of Legends is the game where you team up with people and then you fight literally and then you win the game. But if you just play the game for fun, no problem. But if you are like a professional game player, you don't play the game for fun. You play the game to win, right? So here's another random League of Legends community where people share their strategy. And look at this map. Like, it's just number 1, 2, 3, 4, 5. It's really easy math. It's not even like I learned how to count numbers, how to read numbers when I was 5. But if you never played this game, you'll never understand the meaning of these numbers. Same for these academic papers. If you never played the game, like implementing this kind of visual diametry algorithm ever before, this math will never make any sense. And then actually the mathematical level here in this paper specifically is not that bad. If you have undergraduate degree in any engineering field, it's just really simple. It's just optimization algorithm. And then you don't really implement mathematical formula like this in the code because you'll be most of the time using the PyTorch algorithm. And then it's just how you want to formulate your loss function. And that's it. It's just all code. So what companies are looking for is the player, but not just a player who knows the game rule, but strategical player who plays the game to win. When I was a kid, I loved playing soccer, like where one kid, a random boy, kick a ball to any direction in a random direction and entire kids are just following that ball. However, if we look at this professional play, the players don't move like that. They are moving as a formation like this, right? So that's the strategical play. And then companies are looking for the candidates who can play with the strategy. So also it kind of connects with the tips to how to write their resume. Like a lot of people just literally list what they have done in the project. Like, hey, I have done this object detection. I have done this navigation algorithm. And then they just put that resume. But to stand out, I'd say I had this problem and then I used this algorithm and then the result got better. For example, like this, to improve this error state estimation, I used Kalman filter to the output of the deep learning, like DeepVO, something like that. And then you solve the problem and then how the result got better. And then you just try to kind of cram that into 1 or 2 sentences for your bullet point in your resume. So that's what you want to do. Don't just list what you have done. Try to list what you try to solve and why you use the strategy, that specific strategy to address the problem. So that's what the companies are looking for instead of you have a certain degree and so on and so on, right? So that's the most important thing. Also, I kind of generally agree with this traditional title of the degree, like mechanical engineering, electrical engineering, computer science, and so on. I understand it's generally important. However, in practice, I think it's more important to categorize your work in terms of the functionalities of the robots in general. And that's exactly why when I create this website for the robotics lectures, I categorize these lectures in terms of autonomous navigation, perception, and AI, parentheses, decision making, and then robot nervous system, which is embedded system. And then you want to separate maybe your interest within this specialization, maybe all of them. And here's the reason. I didn't just make up this website. So let's actually go over these job descriptions together for now. Also, when you search for your job I'm just using Indeed.com just as an example because it's the most general job searching site. When you actually search, for this one, I believe I have typed robotics engineering or humanoid robot, and then this one came out. Then salary range is kind of I think is average, and then go down, and then they just describe the role, autonomy team, robotics generalist, and what you will do is contributing your architecture to autonomous system to make it scalable, robust, and so on and so on. Yeah, gotta be safe. Yeah. Now you understand why they mention the safety, right? The robots can hurt not only you, but your clients, and that is going to be the problem in the part of the business, right? Anyways. So, so on and so on, and then what you will bring. This is your minimum qualification for this kind of job position. So, experience implementing calibration routines for the typical sensors that support autonomy, i.e. cameras, LiDARs, and IMU. And then most people would be like, well, I know cameras, but yeah, a bit of LiDAR, but what is IMU? What the heck is that, right? And then we'll be working the small team. You need some good personality and good attitude and that kind of thing. So also, if you are kind of new to this field, you also get the new information from this job description. Like for the typical sensors that support autonomy, and those typical sensors for autonomy is camera, LiDAR, IMU. So you got new information, and then that's the starting point where you need to search your study list and something like that. And the typical sensors are like IMU, totally. And that's why I created Robotics 101. For example, I talk about this kind of IMU. IMU is actually the inertia measurement unit. Now, if you actually go down, then there is level 1 and inertia sensors and so on and so on. We try to do control algorithm as well, and then boom, here's the IMU theory. So this is one bullet point that you need for this kind of robotics job posting. And what kind of robot do they actually make? Automation AI solutions to transform agriculture and beyond. So it's autonomous vehicles, I think. It's a generalist in autonomy team. So yeah, you need some sensor fusion skill sets to afford this position. And then this position salary range is like that. I mean, not bad. And then next one actually found is literally from Tesla Optimus team. The maximum salary range is like, I want to go there. Yeah, right? And then anyways, yeah, what you will do is a minimum qualification for this team. This is a humanoid robot. And again, design, implement, optimize state estimation algorithms like EKF, UKF, and what the heck is this word, right? For humanoid robots. IMU, again, IMU, joint encoders, cameras, again, force torque sensors, and so on. And they analyze, improve estimation robustness in presence of sensor noise. So they are looking for some people who understand this kind of real-world problems instead of people who are just excited about the fact that robot can do backflipping. So again, what is this EKF? Like, it's extended Kalman filter. And then that's why I talk about Kalman filter and extended Kalman filter like that. So extended Kalman filter, and then to be able to understand Kalman filter, you want to know a state-space method, and then to be able to understand state-space method, you want to do basic IMU theories, and then to be able to understand IMU theories, you want to know a little bit of control theories, and that's why I talk about this control algorithm. This is a very simple control algorithm like PID. So one question I got from my followers that, hey, Elliot, I'm interested in humanoid robot. Why are you talking about IMU? I don't know. What is the point of saying that? Are you just teaching drones? No. Well, here, the state estimation engineer for Optimus Tesla is for the engineers who know IMU. Why is that? Because IMU is actually the inertia sensor, and your Tesla robots want to maybe interacting with people, and that is moving head literally, and that it wants to know is orientation, like angular positions and all that kind of things with other sensors together in a dynamic environment. So in an ideal case, if you have a drone that has a really good IMU implemented, you take out that computer from the drone and then put that computer into head of your Optimus. It sounds like Optimus Prime from Transformers. Anyways, that is going to be that IMU, same IMU. Or literally, if you don't like all that, if you take out the head of that humanoid robot and then try to scan the area, and that's going to be the structure for motion, what the civil engineer is doing, right? So all these engineering fields are connected. And then when it comes to drone, it's the most extreme environment because the drones are like not only doing backflipping and then moving very fast velocity, and then that has all these dynamic issues in real engineering problem. And if you really understand these issues arising from the drone application for IMU, I'm pretty sure you will be very comfortable with this kind of job descriptions. So again, I don't want to make the lectures like kind of fancy data visualizations tools and then some kind of popular AI algorithms like YOLO V8 and that kind of things. I mean, if I really try to target that, I might be able to gather more, excited people and then sell my lectures and I'd be happy. But what you really want is actually this kind of range of the salaries, and to be able to be prepared for this, you need all these bullet points. You need to understand this. And then again, even if you read the research papers, like I said, it's not a tutorial book. Research paper is more about strategy book. And I see there's the gap, right? Research paper is a game strategy book, but the companies who want their strategy player, but they are really lacking robotics materials to just the tutorials, right? Even before the strategy. And that's the motivation of making these lectures. So I really prepared these lectures towards this kind of job preparation. So I understand if you're new in this robotics field, you are fascinated by these cool robots doing crazy things, right? I was like that too, I understand. However, if you are just not doing the robotics for a hobby, these kind of keywords like strong background in state estimation, sensor fusion is what you really want instead of this fancy data visualization robotics courses. So let's look at another job description as well. It's from NVIDIA, this is senior role, senior sensor fusion engineer, autonomous vehicles, and then go down, SOTA perception, DNA and mapping, map signals, level 3 autonomy in highway scenarios, and creating accurate, reliable, safe models of the world from camera, LiDAR, radar, perception, and there's so much requirements are there, and so on. And what they need to see is bachelor's, master's, PhD in computer science or related field or equivalent experience. I think that this related field is really interesting because when I was doing my master's, one of my thesis committee is a civil engineering professor. Why? Because I'm more like a robot navigation, that kind of guy, but why the hell this civil engineering professor was one of my committee member? Well, civil engineers are not just like building bridges and tunnels. Instead, they measure the landscape. To measure the landscape, it's about the 3D space recognition ability gotta be there. And literally, if you take out the head of your humanoid robot and then scan the land, and all of a sudden that becomes a civil engineering problem, right? And then if you do that again, back in the robotics, and then do that in real time, all of a sudden that becomes a robotics problem because the robot needs to understand the 3D space to be able to interact with humans in real time. So that's about the robotics, and then all these fields are really connected. And that's why they put related fields or equivalent experiences. Then passion is always important. And then ways to stand out from the crowd. Well, this is really important. 3D computational geometry, computer vision, sensor fusion, localization and mapping, trajectory, optimization, and state estimation algorithms like Kalman filters again. I told you, like, guys, Kalman filter #1 robotics interview question like this. Kalman filter #1 robotics interview questions. It's not just #1 robotics interview question. It's just almost like must. Like, don't you see the pattern? Almost every job posting never miss the word Kalman filter. So you want to know that. And that's really the basics of basics. And again, your goal is this instead of a taxonomical categorization of the title of your degree, okay? And this is another job description from this company, and the salary range is still not bad. The perception, planning, prediction, localization, and so on. And so what is the localization? So if you actually go to my course page, I'll put the link down in this description section or comment section, so check that out. So if you actually go down in this autonomous navigation specialization, I talk about computer vision, where you need to see the 3D information. And then visual odometry. Visual odometry is about how to measure the frame-to-frame motion of your camera. And then you can do the same thing with the deep learning. And then SLAM, simultaneous localization and mapping. Now, if you actually get into this page, there's a bunch of waitlist there because I am planning for this after Robotics 101. And this is an example of the localization and mapping problem in robotics in general. Although this example comes with the car-mounted camera, and that literally just by looking at the camera, you can not only track the position of the camera as it moves, but also you can create the map around this environment. And then this is called typical GPS-denied environment because think about it, if you're a humanoid robot or you're serving cart robot in a restaurant, obviously it doesn't have any GPS connection. Or if there's a car in a garage, right? So you need to solve this GPS-denied environment. And that's one of the solutions to this kind of problem is called simultaneous localization and mapping. And then most of the cases are out there with the raster examples and so on. They do these car-based examples a lot, but not much with the 3D. I mean, this is still 3D, but the dynamic movement is kind of constrained on the ground. So I included this data set, this is called the URC data set with this drone-mounted camera, and then doing the same thing. So again, even if you are interested in humanoid robots, you need this ability for your humanoid robots to be able to walk around. Like, ask yourself, if you're a human, if you walk around the street, how do you manage the walking while you're not bumping into the random strangers on the street? And that's called the navigation problem, path planning as well. So in robotics, even if you are building a humanoid robot, this navigation algorithm core is not that totally different from the navigation algorithm from the self-driving cars. So that's why you might want to look into this kind of keyword, SLAM, simultaneous localization and mapping. And if you're interested in joining this course, well, waitlist is out there. When you search for the rest of the jobs, go to specializations and then use the keywords from this page. For example, don't just type robotics engineer or engineering researcher or something like that. Instead, type visual odometry, object detection, RAS2, Pixel as well. So what the heck is that? Well, it's about the autopilot computer for the drones and autonomous vehicles. That is actually practical. Yes. So if I actually go down here, senior guidance navigation and control engineer, and this is actually the UAV position, aerospace GNC, navigation and control guidance, that kind of things. And then if you go down, you will, it says you will do this and this. These are the minimum qualifications, like some numbers of experience and then proficient with C++, Python, simulation tools, MATLAB, Gazebo, ROS, and then PX4, ArduPilot. So what is the PX4? Let's see here, Pixel and PX4. I talk about that. I talk about ROS2. I mean, I will be talking about because it's still our wait list, but that's my point. I don't just create the lectures to amaze people. I really want you to be able to understand at least the job descriptions before you apply. Why is that? Because when I was working, luckily, thankfully, I was able to join in the interview process of the company. And then whenever I go through this resume and then actually technical interview process, people are like, hey, actually, I'm a computer scientist. Why do I have to touch and worry about the BLDC motor of the robot? Well, thank you for saying that. You're not a robotics engineer. So skipping that. But I had so many people they come with this segmented perspectives of this traditional categorization of the degrees, like computer science and mechanical. Let's not do that. I mean, in the real world, there's no such thing. Like in this 21st century, on the map and the planet Earth, there's no country borders, but the country borders are there. It's artificial. Just like that, this categorization is artificial. Mechanical engineering, computer science is artificial. Don't focus on that. You just got to solve the problem. So that's my point. The last one, machine learning engineer, frontier AI and robotics from Amazon. And I chose this because it's most general, because they don't even bullet point all these skills. Instead, they just throw all these fluffs right here. Our work spans the full spectrum of the robotics intelligence, from multimodal perception using images, videos, and sensor data to sophisticated manipulation strategies that can handle diverse real-world scenarios and so on. So this is one most important question for me to be able to guess what kind of skill sets they are looking for. Like they said images, videos, it's about the camera, and then sensor data. Now you know what kind of sensor data they are talking about. What kind of sensor is it? All the other robotics companies are mentioning that IMU, camera, LiDAR. So those are the sensors kind of mentioned like umbrella terms, right? And that's the point, how you want to prepare for the future potential interviews. When they say various sensor data and that you want to introduce, if you have ever chance to interview with them, you want to introduce yourself with these keywords like images, videos, and sensor data. So if I apply for this, I'd introduce myself as, hey, I'm Elliot. I have been working in the autonomous vehicles in general, and I have been working with state estimation and then IMU, and then I was able to integrate the IMU data with the images together, and then I was able to increase the accuracy of the prediction of this camera movement from here to here with the integration of IMU and without integration of IMU and something like that. I don't know. But that's how you want to introduce yourself based on these job postings like this. That's quite vague. I don't know what's the point of having this kind of job posting Amazon. But anyways, well, that's the salary range. Is still pretty good, so no reason to skip this kind of job. And then I've been talking a lot about this 3D perception in robotics today. There are many other things as well in robotics, but I'll be releasing the courses in autonomous navigation. And then the reason why I kind of prioritize is the navigation, 3D perception, that kind of thing. And that's because really the AI's next challenge will be the spatial intelligence. And here's my favorite figure, Fei-Fei Li. She is called the godmother of modern AI. Y Combinator just uploaded this talk with Fei-Fei Li, so check out.
The world is far more complex than that. First of all, the real world is 3D. Within space, it's fundamentally 3D. So that by itself is a much more combinatorially harder problem. Second, the sensing, the reception of the visual world is a projection. Whether it's your eye, your retina, or a camera, it's always collapsing 3D to 2D. And you have to appreciate how hard it is. It's mathematically ill-posed. So you have to, this is why humans and animals have multi-sensors, and then you have to solve that problem. And third, the world is not purely generative. Yes, we could generate virtual 3D world. It still has to obey physics and all that, but there is also a real world out there. The utility, the use cases are very different. If you dial all the way to generation, we can talk about gaming and metaverse and all that. If you dial all the way to real world, we're talking about robotics and all that. But all this is on the continuum of world modeling and spatial intelligence. There's a lot of data on the internet for language. And where's the data for spatial intelligence? You know, it's all.
Yes, she's basically talking about the current roadblock of the AI is about the 3D information, because AIs can generate, they can even generate the videos like Google VO3, but can this AI accurately perceive this 3D space in real time? And by the way, speaking of that, this is a really interesting discussion. So during my master's, I worked on this deep learning for visual inertial odometry and that kind of things. And then Honestly, I was really frustrated by this deep learning architecture. It was cool, and that's how I was able to graduate with my master's. The problem is, without the data, it may not work. I mean, it will not work, I'm pretty sure. Without the data, it will not work. For example, if you train your robot navigation algorithm, if you need to send a Mars rover to Mars, the planet Mars, is that going to work? Will it work? Because if you train the data from the Earth, yeah, that's a good question, right? I'm pretty sure the Mars rovers, if you actually go to academic conference and people from NASA present their work, and then they are not using deep learning. They use this traditional method based on the feature-based trackings and so on. I mean, it was like a couple of years ago though, but that's really an interesting point that I wanted to make. So when you use AI in robotics, you want to know what you're doing, what is your ultimate goal that you want to solve with this AI, because you might not want to use AI at all sometimes. The wait list is out there, and then the courses will be coming out from end of July, August, and September. That's my goal. Finger crossed, it's a lot of work. Also, make sure when you search the robotics job, don't just type robotics engineering. Use the keywords from this. Okay, I think I have a lot more to say, but I think I should stop here. It's already pretty much way longer than my average other videos. So I'll stop here today. And then don't forget to like and subscribe. I'll be uploading more helpful tips like this in the future, so don't miss that out. Subscribe my channel. My name is Elliot. Thank you for watching. I will see you around.